Hello, everyone. This is Module 6, Part 2 of Chapter 6, Transforming Data Models into Database Designs. Where we left off was we were going through Chapter 6 steps for transforming data models into a database design, and we completed Step 1, where we created created a table for each entity. We uh, placed all of our key placements. We determined what our primary keys were. We indicated what our alternate keys are. We indicated what our data types are for each one of our columns. Our null status, our null, not null values for each column, as well as verified normalization. Now, in step 2 of the transforming stages, this is where we create the relationships in our tables based off of what our maximum cardinality crow's feet notation is indicated in our ER models. Okay, so how we create relationships in our database design is we have to indicate what our foreign key placement is going to be. So the first thing that we'll take a look at in regards to foreign key placement is relationships between strong entities. Okay, in a one-to-one situation, one-to-many, and many-to-many. And then we need to identify relationships that are identifying those that are considered ID dependent or that parent-child type relationship. And then we need to determine if we have any mixed relationships, and then our super type subtype entities. If we have any of those, we need to go ahead and transform those into database designs in regards to creating relationships between those super types and subtypes in a database design. And then lastly, any urinary relationship or degrees of one or recursive relationships, we need to take a look at those the same way that we take a look at, or using the same concepts that we've used between our strong entities. Okay. So first, in terms of primary key and foreign key placement of one entity into another entity, in a one-to-one situation, since there is no parent and there is no child, it really doesn't matter. So either design will work. So if you have a one-to-one binary relationship between two entities, you can take the primary key of one and put it in the other, and then vice versa. You can take the primary key of the other one and put it as a foreign key, and it really doesn't matter. The only considerations that you have to take in consideration is there may be some design aspects if your minimum cardinality is either optional to mandatory or mandatory to optional. Depending on what that is will depend on what you would need to do in regards to your database design. But we'll talk about minimum cardinality and how we enforce that in step 3 of this chapter. So, but for now, in terms of our maximum cardinality as far as our foreign key placement, notice in this example here with our two examples of club member and locker, either way it'll work with a foreign key from member number placed into locker in our first example at the top there, as well as the primary key of locker placed into member number as a foreign key in our second example in B. So either one, either design will work if you have a one-to-one strong entity type relationship. Now, if we have a one-to-many strong entity relationship, now we're talking about a parent-child relationship where we always want to take the primary key of the entity on the one side and place the primary key of that into the entity on the many side, which is considered the child. Okay, so we always want to place the key of the parent into the child to create that relationship. Okay, so here's the example of a parent-child relationship between club member and club uniform. Notice in A is our entity diagram where member numbers identifier, uniform ID is our identifier, and our other attributes. And then in B, you see that member number now becomes our primary key of club member, and then member name, phone, and email become our non-key attributes or columns in our club member table. And then we're placing the member number primary key into what's considered the child, or on the many side of the relationship, into club uniform as a foreign key. Okay, now we've created a um, a relationship between club member and club uniform. It's very important that you notice that this is considered a non-identifying relationship. So because it's non-identifying, the foreign key placement is just again considered just a foreign key and not a composite primary key, as if it would be identifying between member number and uniform ID. Okay, so again, this is what we do. Always place the primary key of the parent into the child on the many side. Okay. Now, if we have a many-to-many strong entity relationship, this is where things get a little more complicated and we have a little bit more work to do. In a many-to-many strong entity relationship, there is no place for a foreign key. Okay. Because the simple fact is a company can supply, in this example here, a company can supply many parts, and a part can be maybe supplied by many companies, right? So there is no place to put a foreign key. So what we have to do is, in these situations, is we have to create what's called an intersection table, okay? The intersection table stores data about the corresponding rows from each entity, the corresponding rows from that many-to-many type relationship. Okay. Now the intersection table will consist of only the primary keys of each table, which will form a composite primary key in that intersection table that maps back to its parent. Okay. And then each table's primary key also becomes a foreign key, linking it back to that particular table. So in this particular case, as you see at the bottom of this slide here, our new table, which will become company underscore part underscore int, will be abbreviation for intersection. Notice we have the company name and the part number as primary keys together as a composite primary key. Okay. Let's see here. The next slide here shows us what we've done in regards to creating that intersection table. So again, we had a many-to-many relationship between company and part, and what we've turned that many-to-many relationship into is two one-to-many relationships with our intersection table. Notice company name and part number are the composite primary key of company underscore part underscore int. And then there are also foreign keys that map back to each one of the parent tables. Okay, therefore, the relationship should be considered as identifying. Okay, we'll see. You see with our solid lines. Okay. So when we start talking about ID-dependent entities, typically we're going to have four uses for ID-dependent entities. ID-dependent entity is how we represent many-to-many relationships. Again, if we have a many-to-many type relationship, we're going to break that down into one-to-many relationships. We will never, in our table designs, leave a many-to-many type relationship. Then the other ones is how we represent what's called an association relationship, and then how we would store our multi-valued attributes, and then how we would represent our archetype instance relationships. Okay, but these are the four uses for ID-dependent entities. And again, what we need to understand is that ID-dependent really is indicating how that new table that we're creating, what is going to be considered its primary key. So more than likely, if it's ID dependent, it's going to be some type of composite primary key that typically maps back to another table. Okay. So the first example we've already talked about an intersection table that holds the relationships between two strong entities from a many-to-many relationship. Again, only primary keys that form a composite key, a composite primary key that are also foreign keys that map back to their original table. Now, the second way we represent ID-dependent entities, remember we talked about what's called an association table. Okay, so what an association table is, a association table has all of the characteristics of an intersection table, meaning, again, we pulled down the primary keys of both tables from that many-to-many relationship, but we also have added another column of attributes excuse me, specific to the association of the other two entities as a additional column or additional attribute in that association table. So, excuse me. So in this particular example here, you just notice that we're associating a price with a specific part number and a specific company name. So that now, because we've added an additional attribute, this particular new table now becomes what's called an association table. Now, in a multi-valued attribute, which is our third example, for multi-valued attributes, what we need to do is kind of the same thing as we would do with an association table. However, what we're doing in this particular example with company and phone contact, obviously phone contact is our multi-valued attribute, or phone number is. So we're going to associate a specific phone number with a specific company and that particular contact name. So contact would be the primary key of our new table, where company name would be the foreign key that maps back to the parent table in a multi-valued attribute scenario. So in phone contact, now we have a composite primary key where only half of it maps back to the parent table and the other half is the primary key of the new table. Same thing with our archetype instance. We're going to be using the same type of concept in regards to transforming that data model into a database design where notice the same type of relationship, because it's an identifying, an ID dependent type entity. Because it's ID dependent entity, that means that the class name from the parent table or parent entity has to be included as in the key or the primary key of the child entity or child table as a composite primary key. So the same type of concept as we did with multi-valued attributes is the same type of concept or rules that we would apply for the archetype instance pattern. Okay. Now, if we're representing or transforming relationships that use weak entities, now we go back to our rules. Is that, you know, even though like in this particular example, section is considered a weak entity, and it does not necessarily have to be an ID dependent type situation. So in regards to transforming that particular entity and creating a relationship, what we're doing here is we're just simply again making our identifier, which is reference number, mapping over as the primary key of our section or our weak entity. And then notice, since it's non-identifying, in order to create that relationship with the parent and the child, all we're doing now is taking the primary key of the parent, which is class or class name, and inserting it as a foreign key into the child table as a foreign key. But notice it's not included in its primary key value, so we don't have a composite primary key as we did in our ID dependent or identifying type relationships. Again, in most cases, you know, like especially in some of the examples that we'll do in our assignments, there will be a lot of what's called mixed entity type relationships where you'll have a combination of identifying or ID dependent and non-identifying or non-ID dependent type relationships. So in this particular example here, we have, remember we had this a many-to-many relationship between employee and skill. So what we had to do was we had to break down that particular many-to-many relationship into a one-to-many with some type of association table where we're associating a specific course taken or proficiency level with a skill number and an employee number. Okay, so based off of that, what we're saying here is based on the minimum cardinality between skill and employee, and then the maximum cardinality between skill and employee is both many. What we're going to do is create both a ID dependent with employee number and skill number, employee number included into the employee underscore skill weak entity, and then the skill, but notice the skill relationship between skill and employee skill. There is no since it's not identifying, there is no foreign key placement for, the foreign key placement for name is included not in the composite primary key, but it's added as a foreign key into our table. All right, so this particular table, employee underscore skill, because it's a mixed entity, ends up with two foreign keys that map back to the associated tables or associated entities that we've transformed. Okay, and here's just another example of where we had taken the data model here. And notice here, since we, if you have a mixed entity type relationship where you have some non-identifying and identifying relationships in your ER model, I guess what you need to pay most close attention to is what are my identifying relationships or our ID dependent relationships. Because if I have an ID dependent relationship, then I know that I'm going to have some type of composite primary key. Whereas in all of the non-identifying relationships, all I'm doing essentially is creating, doing some foreign key placements from the one side to the many side as foreign key values. So here, as you can see, our only ID dependent relationship is between sales order number and order line number. So here we notice we have a composite primary key where half of it is a foreign key that maps back to its parent. But in all other relationships that we've created, again, we're taking the primary key of the one side and placing it as a foreign key on the many side, and here customer ID on the one side as a foreign key here, and the sales ID on the one side and to the many side as a foreign key here. Okay, so essentially we've created relationships or mixed relationships with all of our entities in this particular relationship pattern. Okay, subtypes and supertypes are real simple. Notice in our data models here, we've already talked about in our entities that if we have a subtype relationship between a supertype and subtype, the subtypes must have the same exact identifiers as the supertype. So notice in our database design, what we're simply doing is those identifiers become foreign key values as opposed to primary key values in our subtypes. And in our supertype, we notice that our discriminator just becomes another attribute in our table as we discussed, and then our identifier or student ID becomes a primary key in our database design. So these are just straightforward in regards to transformation from our entities to our database design is straightforward. Essentially, the subtypes, which are essentially what a supertype is, their values or identifiers, which is the same as the supertype, just become foreign key values that map back to that particular supertype. For recursive relationships, if you find this confusing, Um, this is, we always use this particular example in regards to Boxcar as the one that kind of makes the most sense. But essentially, what you would do for recursive relationships is all of the same principles that we talked about for our one-to-one relationships and in our one-to-many relationships in terms of foreign key placements. Foreign key placements would apply the same way as if we had a binary relationship as opposed to urinary. Okay, so again, all of those concepts for foreign key. Now, of course, with a many-to-many relationship, here notice in this particular example, we created this intersection table here with part and int from part to part underscore intersection table. So pretty much this part contains a specific part that maps back. So this is what we would do um, for those many-to-many type relationships. Okay, well, this is the end of part 2.